to our next speakers. We've got a team, Dr. Nader and Dimitris. They will present how Earth observation is helping agriculture from Lyrasense. Please, guys, the floor is yours.
Thank you. I hope you can hear me well. So the presentation will be basically two parts, and we'll try to stick to the time allocated. So we're a software startup that is building basically our software to democratize Earth observation application development. And today, Dimitris, my co-founder, and I would kind of like give you an overview on how we see things develop in terms of the market, as well as technology, with the Earth observation for agriculture, and end with a quick demo of our product. And then we can discuss further steps and questions. So basically, the bigger picture, Earth observation. We've been collecting data about our planet for more than 45 years now. Aggregated almost something like 800 petabytes of data. 90% of this data has been collected only over the past 2 years, so it's growing at an exponential. And basically, this data is fully leveraged, can boost our economy on one hand, but definitely have huge impacts on our environment, from greenhouse emissions, etc. But today we're focusing on agriculture. So when we look at the landscape, you see that the potential of global economic value from agriculture exceeds 390 billion US dollars, as estimated by the World Economic Forum on a recent study. Diving deeper into this, we find out that 85% of this value is driven by precision agriculture applications. So what happens on the Earth observation side and in the development there? We see a rise in popularity within hyperspectrum, and they basically promise around 50x the value of insight that you can drive from the typical satellites. So what that essentially means is that you're basically collecting a bigger range of the electromagnetic spectrum within every pixel, so that you can see things that were previously unseen. So within agriculture, that covers areas of plant health insights, soil health, and we kind of discussed in the previous presentations, detecting parasites and kind of stress levels early on to prevent losses, etc. And basically what Lyrasense plays here is critical role. So Lyrasense, as I mentioned earlier, we're like this enabler in between. So we're a software that kind of simplifies and accelerates the development and deployment of these applications. So essentially, we sit at the intersection of the data providers and the end users. What we do is that we make the connections and data integrations pretty easy. So we're trying to simplify all the current status of downloading these huge data sets, re-uploading them, processing them, etc. We're kind of like streamlining that, giving our data scientists or remote sensing geospatial experts a workspace where they can integrate these data sets directly, build their application, train their model, with us taking care of all the back-end computation, data handling, etc., in the most efficient way, so that they can eventually deploy their end application. So kind of like looking deeper into that, it means that we're working on the data provider side, all these integrations on here and how we connect them. We offer basically a cloud development interface, but also very visual interface for those that are not familiar with coding and have that kind of expertise. And on the other end, we ease the integrations with the typical apps, so from Excel, Power BI, to ensure that whatever system you're running in your organization, this would integrate with. And maybe to kind of like highlight the benefits. So other than the ease of use, our users kind of benefit from at least 3 times faster time to market and deployment of the applications. We're talking days instead of the typical weeks, and at least 70% lower cost in terms of the computation and data. And maybe now is the time to kind of give the floor to Dimitris to show you a quick demo of our product. Keeping in mind that we're an early stage startup, currently supported by their European Space Agency and some of the biggest startup systems in Europe.
Thank you, Nader. If you can,
Yes.
stop sharing so that I can
sharing.
yeah. Thanks a lot. And hello, everyone. Okay. So now you should see my screen, hopefully.
Yes.
All right, so this is a prototype demo. As Nader said, our software is a workbench for remote sensing and geospatial experts. The idea is that here you can organize your work. For example, you have your projects here, and then first thing you need to do probably is find some data, right? So then we have a lot of open hubs as providers that you can get data from, like connect with your credentials, and basically then, or even upload your own data here, and then you need to like find those data and create a data source. So, for example, let's go here. This is about like example is already there. We can search, put some filters, and then you will find these images that are either from Open Hubs or that you already uploaded yourself. And then the big in terms of data, the big thing we are adding in terms of convenience is we allow you to create data cubes that can, like, you just select your images, or you can also do it with a save file or an Excel sheet, and then after you have the images you wanna include, you build a data cube, and this will happen basically in the background in our backend, and you don't have to worry about anything. Then you can just access it with Python in a very easy way. So after you build this kind of data sources that you can use, if we go back to the projects, you have the workspace. So the workspace is a combination of visual and code editor. So here you see an example use case where we have landslide detection use case. But basically what's happening here is that you can create those code blocks, basically, that, for example, this one is opening the data cube, and then do some kind of processing, or like basically your normal workflow. But then you can also structure this visually. And for example, if your team, you have some people that are technical and some people that are not so technical, you would be able to have, like, the technical people, build these kind of blocks, and then the rest can, play around and compose them and like connect them and everything. So then when this is created, basically you can hit deploy flow, and then this will take this whole graph and deploy it in our backend and execute it. And in the end, what you would get is some kind of app where you would be able to see the different outputs of the flows. Something that still we're building is an app builder, so that you could have like web apps or dashboards that you want to show to your users in the end. And of course, you have all the like kind of usage things, since it's a cloud platform, and we charge people for storage and compute, and some kind of governance things like organization management and API keys and stuff. So the API keys may be the last thing, and then I give it back to the moderator. Is that we also want to give you the option to like work purely on code if you're a more technical person. So this is why we also have an SDK that can easily be integrated in your workflows, and then like integrate also with our platform. Yeah, so that's from my side. Thanks a lot, and I'll stop sharing now and give it back to moderation.
Thank you so much. Thank you so much for your presentation.